Okay, we're solving a trig equation. Here it is. Sine of 3 theta equals -1. All right, so first thing, we don't know how to deal with this 3 theta. So what we're going to do is we're going to call it alpha. So in the back of our mind, we're going to know that alpha is really 3 theta. Okay, so sine of alpha equals -1. Now we can solve that and work that out pretty easy, because where is sine, or the y value, -1? As we go around, the y value here is 0, y value here is 1, y value here is back to 0, and y value here is -1. So that angle right there, which is 1.5 pi, will be our answer. And that's the only place it's equal to -1 within this possible range. Now, we can say then that alpha is equal to 1.5 pi, but it's also equal every 2 pi times k, where k is an element of the integers. Okay, so let's solve this out from here. Let's substitute back. We just borrowed it for a little bit. We'll just substitute this back. And so we now have 3 theta equals 1.5 pi plus 2 pi k. Okay, so to solve out, I just divide everything by 3. So I have theta equals, well, 1.5 pi divided by 3 is pi over 2. Plus, this is 2/3 pi times k. So we now have to figure out, where is this answer right here good in our range right here, in our possibilities there. Okay, so we go pi over 2 plus 2/3 pi. That's one answer if k was 1. Theta could equal pi over 2 plus 2/3 pi times 2 if k is 2. All right, we better figure those out. We have to get a common denominator. This is going to be 3, 3, and we're going to multiply this by 2 and 2. So this will be 3 pi plus 4 pi, or 7 pi over 6 is one answer. So we have our first answer is pi over 2. That's easy if k is 0. Second answer, 7 pi over 6. Our third answer, let's do that. Multiply this by 3 and this by 2. This gives us 3 pi plus 2 times 2 times 2 is 8 pi. So that's 11 pi over 6. So we're almost to 2 pi with that answer. So it looks like if we had gone to k as 3, we'd been over our theta value that we're restricted to. So therefore our answers, I should say, half pi, 7 pi over 6, 11 pi over 6.